This is Bob Capetta from the University of Illinois at Chicago, and this lesson is on graphing sine functions. You should always start with the unit circle. Recognize that the sine corresponds to the y value. Cosine corresponds to the x value. So if I'm at 0 degrees, the sine has to be y. If I'm at 90 degrees, the sine has to be 1. 180 degrees, sine has to be 0. 270 degrees, sine has to be negative 1. So indeed, sine of 0 is 0. We want to convert to radians. We saw sine of 90 is 1, but 90 is pi over 2 radians. So sine of pi over 2 radians is 1. 180 degrees gives us a sine of 0, and that of course is pi, so the sine of pi radians is 0. And down here at 270, sine of 3 pi over 2 is negative 1. And finishing it, ending up at 2 pi, you'll notice we're back at 0. So the sine of 2 pi has to be 0. So generally speaking, for one cycle of a sine function, I want to have 5 points. The beginning point, the ending point, the midpoint, the quarter point, and the other quarter point. Those 5 points will help us graph that sine function. So we've got all those. We want to see what that sine function looks like. So let's look at 0, 0, pi over 2, 1, pi 0, 3 pi over 2, negative 1, 2 pi 0. So I've done that here. 0, 0, pi 0, 2 pi 0. Pi over 2, boom, we jump up to negative 1. 3 pi over 2, we jump down to negative 1. So that's enough for us to graph our sine function. So what will that sine function look like? It looks like this. And of course we could zoom it out and you can see that there's many, many more cycles of this that go on forever. But our primary cycle, our 0 to 2 pi cycle, starting point, end point, midpoint, quarter point, quarter point. Those are the 5 points that we need to generate our first period of our sine function. So our next example is y equals 3 sine x, and you may recall 3 is the amplitude. But I'm still working off those same 5 points, 0, pi over 2, pi, 3 pi over 2, and 2 pi. Sine of 0 is 0, sine of pi over 2 is 1, sine of pi is 0, sine of 3 pi over 2 is negative 1, sine of 2 pi is 0. Why? Because of the unit circle. The sine is the y value. Multiplying that by 3, what do I get? 3 times 0 is 0, 3 times 1 is 3, 3 times 0 is 0, 3 times negative 1 is negative 3, and 3 times 0 is 0. So I want to graph those 5 points and then use that to determine what my sine function will look like. So with the starting point 0, 0, ending point 2 pi 0, midpoint pi. The midline of this graph, the line that sort of cuts it right in half, is the x-axis, is y equals 0. Now the quarter point here at pi over 2 jumps up to 3. The quarter point there jumps down to negative 3. So I have this graph of y equals 3 sine x. Let's see what that graph looks like. And again, you can see start point, midpoint, end point, quarter point, quarter point. And it goes forever. So there's our fundamental period from 0 to 2 pi, but we could indeed, zoom this out and show many, many more cycles of that graph, y equals 3 sine x. The amplitude is 3. It goes up to 3 and it goes down to negative 3. We call that amplitude 3. The period is 2 pi. It completes one cycle. It returns to its starting point and completes the entire up-down cycle once we get to 2 pi. So knowing the amplitude of a sine function and the period of a sine function is going to be important for us. Now we want to take a look at what happens with this kind of a situation. So 3 sine x is what we just looked at, but this is a shift. Shift pi over 4 to the right, shift 2 up. So we'll take each one of our 5 points, shift it pi over 4 to the right, shift it 2 up. Here's our graph of 3 sine x. Shifted pi over 4 to the right, 1, 2, 3, 4. Pi over 4 is one box here. Shifted pi over 4 to the right and 2 up. Shifted pi over 4 to the right, 2 up. Shifted pi over 4 to the right, 2 up. Shifted pi over 4 to the right, 2 up. This peak's a little difficult to see going to have to move it down. Shifted pi over 4 to the right and 2 up. So each one of those 5 points will be shifted that way. So here's our graph of 3 sine x, and we want to do the appropriate shifts. So we'll take these points and move them. And so here's the relevant points shifted over pi over 4 and up 2 in each case. We see that. We want to go ahead and connect those dots. That's our fundamental period of that graph. So let's go ahead and do that. So we can see the new graph with the shift through our 5 points that were moved. That is now our green graph. That is our y equals 3 sine x minus pi over 4 plus 2 graph in green. And here that graph is isolated, removing the original graph. Our next question is y equals 2 sine 4x. So what's happening here? We have 4 cycles in 2 pi. So if you divide by 4, 4 divided by 4 is 1, 2 pi divided by 4 is pi over 2. So I complete 1 cycle in pi over 2. So the period of this graph is pi over 2. Now when I go to other periods, I like to think about the starting point, the ending point, the midpoint, the first quarter point, and the point that represents the third quarter. The start point behaves like 0, the end point behaves like 2 pi, and the midpoint behaves like pi. Sine of 0 is 0, sine of pi is 0, sine of 2 pi is 0. Fine. Now my quarter point here, sine of pi over 2 is 1, and sine of 3 pi over 2 is negative 1. But this has an amplitude of 2. So 2 sine x would just be 2 times 0 is 0, 2 times 1 is 2, 2 times 0 is 0, 2 times negative 1 is negative 2, and 2 times 0 is 0. So that's enough for us to get started. We're going to lay out our 5 points, complete the entire period in 2 pi. And then our amplitude, we're going to go up to 2, we're going to go down to negative 2. Just to clarify that, complete the period in pi over 2. The entire cycle will be completed in pi over 2. Starting point 0, ending point pi over 2, midpoint pi over 4. So we know we complete the entire cycle in pi over 2. Starting point, end point, midpoint here at pi over 4. So the quarter point will be at pi over 8 and at 3 pi over 8. And what will that be? So we saw from the previous chart that our first midpoint, or quarter point, excuse me, goes up to 2. And our second quarter point goes down to negative 2. So these are the 5 points that I need to get my fundamental period for this function. It was y equals 2 sine 4x. You'll notice the period there is pi over 2, amplitude is 2, up to 2, down to negative 2. Now can we see that there are 4 periods between 0 and 2 pi? Well, let's zoom it out a little bit. 0 and 2 pi. Here's 2 pi. Let's count our periods. Period 1, period 2, period 3, period 4. Indeed, we had 4 periods in 2 pi, or 1 period in pi over 2. Starting point, ending point, midpoint, quarter point, quarter point. Let's take a look at one more question here. Y equals negative 3 sine of 2 times x minus pi over 6 plus 2. So the first thing we want to do is we want to graph y equals negative 3 sine 2x. Then we'll shift that pi over 6 to the right and 2 up. So let's keep in mind what negative 3 sine 2x will look like. Well, we have 2 cycles in 2 pi. That 2 tells us 2 cycles in 2 pi. If we have 2 cycles in 2 pi, dividing by 2, we have 1 cycle in pi. So our period is pi. Starting point is 0, ending point is pi. Midpoint is pi over 2. Now, what's happening here with our sine function? Usually the starting point is 0, first quarter is 1, midpoint is 0, next quarter is negative 1, and the ending point is 0. Except we're multiplying that sine function by negative 3. So negative 3 times 0 is 0, negative 3 times 1 is negative 3, negative 3 times 0 is 0, negative 3 times negative 1 is positive 3, and negative 3 times 0 is 0. So let's go ahead and graph y equals negative 3 sine 2x. Again, period is 0 to pi. Let's get our starting point, midpoint, and ending point, and then we'll take a look at our quarter points. So our period is pi. We complete the entire cycle from 0 to pi. So starting point is 0, ending point is pi, midpoint is pi over 2. Now my first quarter point did what? According to this, the quarter 1 point drops 3. So if we go back and look at our graph, our first quarter point here, which will be at what? Which will be at pi over 4, would drop down to negative 3. And our second quarter point would go up to positive 3. So this is what we get. Quarter point down to negative 3, back to midpoint, quarter point up to 3, and then down to pi. So this isn't our final graph, but this is the first graph we wanted. This is the graph of y equals negative 3 sine 2x. Now to finish this, we have to do our shifting. So we can see what we have to do. Shifted pi over 6 to the right and 2 up. So each of our 5 important points will shift pi over 6 to the right and 2 up. So you can see this first point shifted pi over 6 to the right, 2 up. This peak, pi over 6 to the right, 2 up. This midpoint, pi over 6, 2 up. This peak, pi over 6 over, 2 up. And the end point, pi over 6 over and 2 up. And this is going to define our primary period of our final graph. So here's the two graphs together. Colors are pretty similar, sorry about that. And then eliminating the original graph, this is what our y equals negative 3 sine of 2 times quantity x minus pi over 6 plus 2 looks like. And that will conclude this lesson.